Morning, folks. So today we are on the third to last topic of the year. After this, we're going to be going after this chapter. I'm going to work out how to do a test. I'm not sure how I'm going to do it yet, but there will be one coming, so just be ready for it. It'll probably be a PDF I'll post online. You will need to show all your work, or I will not accept the work you do. And I will make it just a tad bit more, challenging, just strictly because you do have access to a lot more resources than you would in a typical classroom. All right, so I only have a time limit in which I can make these videos in, so it's probably going to be a couple of them because this is, it's a little more interesting to explain. Once you get it, it's very easy, but getting to that point is a little more difficult. All right, so today's section is, by the way, all the examples I'm doing are from the textbook, starting on page 651, 9.8. This is called Power Series. Sorry, my handwriting is not up to par this morning. We are doing the Power Series. Now, this section, it's kind of introducing you to what a power series is, which is very brief, and then we're going to jump into something called convergence of power series. Basically, we're going to have this series with n and x in it, and we're going to be able to determine, well, for what values of x does this series actually converge for. And while this is just it's going to help you understand what's going on, it's going to be more important in the next section. So this kind of lays a foundation for the next two. So let's go ahead and dive into it. Let's see here. So the definition of a power series. What is the definition of a power series? Well, there are two kinds of power series. I'm going to go ahead and start using some colors now. So the first power series is going to be what's called centered at zero. Centered at zero. Well, what it means is, if you remember, our Taylor series was x minus c, and where c is 0 makes it a Maclaurin series. So when it says centered at 0, we're specifically talking about Maclaurin. If it's not centered at 0, it's centered at c, we consider it to be a Taylor. Well, Maclaurin is a Taylor, but Taylor's not always Maclaurin. Okay, so we're centered at 0. So that means my power series will look something like this. Assume it's from 0 to infinity. So this right here is what we would call a power series centered at 0. This is associated with the Maclaurin. Now, the other one is centered at whatever value c. Centered at c. Well, what this means then is now my series is defined by something just slightly different. So x minus c to the nth power. So we have the first term plus the next term plus the term after that, so on and so forth, all the way to the nth term, nth term. All right, so then that's going to be centered at c. Okay, so that is our definition of a power series for an infinite series. Okay, so we are going to because we're going to have these things with the values of x on them. Our goal is to define values of x at which the series converges. So let's go ahead and do that. Let's go ahead and define what it means to converge for a power series. So we're going to converge for a power series. Okay, so there are, much like a lot of mathematics, there's always not always, the majority of the time there's three possibilities. It's called a trichotomy. Three possibilities. Well, the first possibility is that it'll only converge at our center. So either at 0 or at C. I'm going to go ahead and define it as C because it's more general for the Taylor series in the future. And that'll work for both Maclaurin and Taylor. So it'll converge, the series will converge at X equals C. Oh, I should say, to be more specific, it will only converge at X equals C. Now the next one. So this next one is there's going to be what's called an interval, essentially. So only where the absolute value of X is minus C less than R will converge. Okay? I'll explain this as we do examples. And then this implies that if this converges, then that means everything greater than that will diverge. I'm going to let you know in hindsight that this will be defined by using the ratio test, which we did the last section. So what we're going to do there is, you'll notice, well, our R will be defined based off of solutions from the ratio test. And that's why we're not using the equal to situation, because if it was equal to, because there was 3 in the ratio test, there was less than, greater than, or equal to 1. If it was equal to, it was inconclusive. So we're not going to discuss the equal to case. Now, number 3, the third possibility is all values of X will converge. Okay. And these are the definitions for this particular section. And now I'm going to go ahead and end the video now, and I'm going to go ahead and work on the next videos will be examples only.